Welcome to Agentic Workflows the Money series, Episode 8, Sub-Agents for Quality Control.
It is good to be back. And today, we are tackling that invisible wall, the one everyone hits when they start really building these systems out.
It is the wall, isn't it? It's that moment where you feel like an absolute genius because
Yes.
you've built this amazing agent.
Right.
And then, maybe 20 minutes later, you feel like you're babysitting a toddler who's just had way too much sugar.
Or perhaps not enough sleep.
Yeah, exactly. We are talking about what we've started calling the drunken intern phenomenon. And if you're listening to this and you've built an agentic workflow, you know exactly what I'm talking
Oh,
about.
you feel it in your bones.
You build a brilliant workflow, it works perfectly, it executes the task, you're high-fiving yourself, and then 10 minutes later, or maybe 10 runs later, it just starts making these mistakes.
Hallucinatory mistakes, yeah.
Right. It starts making things up. It forgets instructions you gave it 5 minutes ago. It starts going off on these weird tangents. And you're just sitting there thinking, you were just working. What on earth happened?
It is the core frustration of agentic development. And the fascinating thing is, it's not because the model suddenly got, stupid. It's because of a very specific technical reality called context pollution.
Okay, let's unpack this. Because I think people hear context window and they just think, oh, that's memory. More memory is better.
Right. The bigger the better.
We have these models now with 200,000 tokens, 1 million tokens. Shouldn't that mean they can remember everything perfectly?
You would absolutely think so. But let's look at the source material we're diving into today. The instructor, Nick Sariev, he lays this out so clearly. We have these massive context windows, yes, but filling them up is not a neutral act. It actually degrades performance.
It's the difference between having a big library and having a really, really messy desk.
That is a perfect analogy. Think about it like this. Imagine you were trying to write a dissertation, a really complex, nuanced piece of work.
Right.
But you're trying to do it while being forced to remember every single word spoken in a crowded room for the last 5 hours.
That sounds like an actual nightmare. I couldn't do it.
Every cough, every little side conversation, every coffee order. That's what we call intermediate garbage. In an agentic workflow, this is the reasoning steps, the tool outputs, the debugging logs. It all just piles up in that context window.
And eventually, brain fog sets in.
Precisely. The brain fog.
Yeah.
The source data talks about this performance curve. When you start at 0 tokens, the model is totally fresh. It's alert.
Ready to go.
Then you give it some context, maybe a few examples of how you want the job done, and performance actually bumps up. It gets smarter.
That's the sweet spot right there.
That's the sweet spot. But as you keep going, as that window fills with all the debris of previous tasks, the accuracy doesn't just dip, it falls off a cliff.
So wait, the more it works, the dumber it gets. Is that what you're saying?
In a single continuous thread, yes, that's exactly what happens. It becomes prone to confusion. It loses the needle in the haystack.
So what's the fix? Because we can't just wipe its memory every 5 seconds if we need it to do a complex, multi-step job.
The fix is what we're deep diving into today.
Oh,
Sub-agents.
Sub-agents.
Okay, it's this concept of isolation of context. Instead of one massive parent agent holding the entire history of the universe in its head, it delegates.
Oh.
A parent agent says, okay, I need this research done. It spawns a sub-agent. And here is the magic. That sub-agent starts with a totally blank slate.
Fresh eyes.
0 context of the previous mess. It has one specific mission. It does the messy work, the searching, the reading, the reasoning. It gets the answer. And then, and this is the absolute key, it reports back only the final result to the parent.
Oh, I see. So the parent doesn't have to read through 50 pages of the sub-agent's thought process.
Nope.
It just gets the 1-paragraph summary.
Exactly. The parent stays clean, the context window stays nice and empty, and the work gets done with fresh intelligence every single time.
That is a complete game changer. And the mission statement for today's deep dive is really specific then. We aren't just talking about building like new capabilities.
Yeah.
We aren't talking about making the agent do more things. We are talking about building the managers and the editors that keep the workers from going completely off the rails.
We are moving from being coders to being organizational designers.
I love that. Okay, so let's get into the specific types of sub-agents.
Yeah.
Because the source material highlights 2 really critical ones that I think every single person listening needs to go and implement immediately.
Right.
The first one is the reviewer sub-agent.
The reviewer, this is all based on what we can call the fresh eyes principle.
Now, I have to play devil's advocate here for a second. Why do I need a whole second agent?
Yeah.
If I have a smart agent, say I'm using Claude Opus or GPT-4, why can't I just say, hey, write this code? And then
Okay.
check your work. Why can't it just review itself?
That is the intuitive approach, isn't it? Double check your work. We say it to humans all the time. But in AI, we run into this thing called creator bias.
Creator bias, okay.
If an orchestrator, your main agent, writes a script, it is fundamentally biased to believe that script is correct
Why?
because it just wrote it. It has the reasoning history right there in its memory. It knows why it made that decision. So when it looks at an error, it essentially hallucinates that the error is actually a feature, or it just glazes right over it.
Ah, so it's like asking a writer to proofread their own essay the second they finish it.
Exactly. You don't see the typos. You see what you intended to write. You see the brilliant argument you thought you made, not the jumbled sentence that's actually on the page.
So the reviewer subagent is basically the mean editor who comes in and doesn't care about your feelings.
Ideally, yes, a ruthless editor. The reviewer subagent gets spawned with zero context of the creation process. It has no idea why the code was written that way. It doesn't know about the struggle the parent agent went through to figure it out.
It just sees the output, the raw code.
And it evaluates purely on quality, efficiency, and security. It is cold, hard, objective analysis.
The source material actually walks through a really specific example of this using Claude Code. Can we walk through that? Because I think seeing it in action makes it really click.
Yes, this was a fantastic case study. So the instructor asks the main agent to create proposal script, a pretty classic business automation task.
Right, take this client info, generate a proposal PDF. Simple enough.
The main agent writes the script, and of course the main agent says, "I'm done, this looks great."
High fives all around.
But then the instructor triggers the reviewer subagent, says, "Hey reviewer, check this script for me." And the reviewer, coming in with those fresh eyes, immediately found a discordant issue.
A discordant issue. That sounds
Yeah.
ominous. What was it?
It was a race condition, basically. The script was trying to fetch a document link before the document had actually finished generating on the server.
Oh, I've seen this a million times. You get that 404 error because the PDF takes like 3 seconds to create, but the script tries to grab the URL in 1 second.
Precisely. The main agent didn't see it because logically, in its reasoning chain, it said, step 1, create document, then step 2, get link. In its mind, that works perfectly. But the reviewer looked at the actual code and said, hold on. There is no waiting period here. This is going to fail sometimes.
So what was the fix it suggested?
The reviewer suggested adding a polling loop, basically telling the script, wait, now check if it's ready. No. Okay, wait another second. Check again. Oh, it's ready now. Now you can grab the link.
And the result of that one little change.
The script went from maybe works, maybe crashes, to completely robust. The error rate just plummeted because the logic was soundly checked by an observer who had no emotional attachment, if we can call it that, to the original code.
That is priceless.
Yeah.
I mean, just think about the business cost of sending a broken proposal link to a potential client.
It's the difference between looking professional and looking incompetent. And all it cost was a few extra tokens to spawn that reviewer.
Okay, so that's the reviewer, the fresh eyes. Now let's talk about the second type of subagent, which I gotta say I think is even cooler. The document subagent, the historian.
The historian, yes, this one solves the drift problem.
The drift problem. This sounds like something straight out of a sci-fi movie.
It feels like it when you're in the middle of debugging it, that's for sure. Here's the scenario. You have an agentic workflow. It has 2 parts. You've got the code, the execution scripts that actually do the work.
Python files.
Right. And then you've got the instructions, the directives or SOPs that tell the agent what to do.
Okay, so the manual and the machine.
Correct. Now you find a bug in the code. So you go in, you fix the Python script, you change an API endpoint, you update a library. The code is now new and improved. But did you remember to update the instructions?
Probably not. I'm
Nope.
terrible at updating documentation.
Everyone is. And that is drift. The code gets updated to fix bugs, but the directives are left unchanged, frozen in time.
So the next time you spin up a fresh agent, it reads the old instruction.
And then it tries to run the new script with the old parameters. And it crashes.
Do.
It's a logical inconsistency that just builds up over time. It's like giving someone a map of a city from 1950 and asking them to navigate the modern streets. The roads have changed, but the map hasn't.
So the document subagent is the one that fixes this.
It acts as the sync mechanism. This agent runs after a workflow changes. Its specific role is to review the execution scripts, what actually happens in reality, and then go and update the directives, the instructions, to match that reality.
It rewrites the manual to match the machine.
Exactly. But here's the crucial detail from the source material that really caught my eye. It's all about permissions.
Permissions, right? This is the security part.
Yes. You do not want your historian accidentally rewriting history and reality. You only want them to record it. So the document agent is given very specific permissions based on the principle of least privilege.
Okay. Break that down. What can it do and what can't it do?
It has read access to everything. It can look at the scripts, the logs, the outputs. It needs to see the whole truth. But it has write access only to the directives folder.
So it cannot touch the code itself.
Strictly forbidden. It cannot touch the .py files. It can only write to the .nd files, the Markdown documentation. This prevents the historian from accidentally breaking the code while it's just trying to document it.
That is incredibly smart. So it's a fail-safe. It ensures that your documentation always reflects the code without ever risking the code itself.
It keeps your whole agent aligned. Self-annealing, as the source calls it. The system literally heals its own knowledge base.
Self-annealing, that's a great term. So we've got the reviewer catching bugs in the moment and the document agent making sure we don't drift over time.
Correct. The short-term and the long-term quality control.
Now, I want to get practical because the listeners are probably thinking, this sounds amazing, but where do these files live? Is this some cloud thing? Is this a button I press? Let's talk about section 3. Implementation. The architecture of control.
Let's get into the nitty-gritty, the folder structure. The source material is using Claude Code as the example, but these principles apply to pretty much any agentic framework out there.
Right. So where do these things live?
In the .claude agents folder, or whatever your equivalent agent configuration folder is called.
Okay. And what's in there? What does it look like?
You have these definition files. They're usually just markdown files. For example, reviewer.md or document.md.
And what goes inside that file? Is it just a prompt?
It's a prompt, yeah, but it's wrapped in a specific structure. The anatomy of an agent file is really important. First, you have the name and description. This needs to be really descriptive. You can't just call it Agent X. It needs to be something like Code Reviewer for Python scripts.
Why does the name matter so much? Can't the parent just figure it out?
The parent agent uses that description to know when to call it. If the parent agent is confused about what the subagent does, it's just not going to use it correctly, or at all.
So it's like a job title. If you have a generic job title, nobody in the office knows what work to send you.
That's a perfect analogy.
Mm-hmm.
Then, next in the file, you have permissions. This is where you explicitly list what tools it can access. For that document agent, you would list can access directives, cannot access internet, read-only access to execution folder. Very specific.
That's that principle of least privilege again. Locking it down.
Yes. And finally, the system prompt. This is the brain. This is where you give it the specific persona instructions. You are a code reviewer. Your job is to critique for efficiency and error handling. Be harsh. Do not be polite.
Do not be polite. I love that.
Politeness costs tokens. Directness saves money.
That is a life motto right there. Politeness costs tokens.
It really does in the AI world. Now, there is one more structural rule that's super important regarding this parent-child relationship that the source mentions.
Recursive limit.
Yes. Agents can create definitions of other agents, but an agent can only spawn a subagent. Subagents typically cannot spawn more subagents.
Hey, why not? Why can't we have grandchildren agents? It seems like it could be useful.
Infinite loops. Imagine an agent spawns a subagent to fix a bug. The subagent then spawns another subagent to research the bug. That subagent spawns another to check the research. Suddenly, your CPU is melting and your credit card is on fire.
Right. It's turtles all the way down, and you're paying for every turtle.
You want a flat hierarchy. Parent spawns a child. The child reports back to the parent. Keep it simple and controlled.
Okay, so we have the files, we have the permissions, we have the structure. How do we actually make it go? Section 4. Execution. How to call and act.
This is the beauty of it. It's not some complex command line script you have to remember. It is natural language.
So I just talk to it.
You talk to the parent agent. You say something like, great work on that script. Now call the reviewer's subagent to check createproposal.py for errors.
That's it. That's the whole command.
That is the trigger. The parent agent interprets that instruction. It looks at its available tool definitions. It sees reviewer.md and its description, and it spawns the child.
And then what happens in the background? What's the flow?
It's what we call the output loop. The child agent is spawned. It loads the file it was told to check. It analyzes it using that fresh, clean context we talked about. It generates a summary or a critique. And then, and this is the important part, the child closes.
It dies. It's a single-use tool.
It terminates. And it sends just the text summary back to the parent. A very short, concise message.
So the parent doesn't get the whole conversation the child had with itself while it was thinking.
Absolutely not. That would defeat the entire purpose. That would be reintroducing context pollution. The parent just gets the final verdict. Line 45 has a race condition. Fix it by adding a polling loop.
And the parent takes that and actually executes the fix.
Precisely. The parent reads that little critique, which is now just a tiny block of text, saving all those context tokens, and it implements the fixes itself.
That is so clean, so elegant. But there's another benefit to this execution model too, right? The speed bonus, the parallelization.
Oh, yes. This is where you start to feel like a real manager of a team. The source mentions that the parent can spawn multiple subagents at once.
So instead of doing task A, then task B, then task C.
You do task A, B, and C all at the same time.
Give me a real-world example of this.
Okay, let's say you're doing research for a new client. You need to check their LinkedIn profile, their company website, and their recent news articles.
Normally, the agent would go to LinkedIn, read, summarize, then go to the website, read, summarize, then go to the news articles.
Which takes time, and it fills the context window up. Instead, the parent says, spawn 3 research subagents. Agent 1, you check LinkedIn. Agent 2, you check the website. Agent 3, you check the news.
And they all run at the exact same time.
They run in parallel.
So if each one of those tasks takes, say, 20 minutes,
The whole job takes 20 minutes instead of 60 minutes.
that is a massive efficiency gain, 3 times faster.
It is. You are moving from a serial process, one thing after another, to a parallel process. That is how you really start to scale these operations.
I can hear the business owners listening to this starting to drool a little bit, but I can also hear the skeptics. Which brings us to section 5, the ROI. Why bother?
The why bother question. And it's a valid one, setting up these Markdown files, defining the permissions. It takes some upfront time. It's not zero effort.
Right, I can just tell ChatGPT to do it and, hope for the best.
You could, but let's look at the numbers. The instructor in the source material found that using a reviewer subagent improves accuracy by a solid 5 to 10%.
Okay, 5 to 10%. Some people might hear that and think, that's not a huge number.
But you have to understand what that 5 to 10% represents in the real world. In a business context, moving from 90% reliability to 95 or 100% reliability, that's the difference between a toy and a production system.
Yeah, that's a good point. If my car only started 90% of the time, I wouldn't call it reliable. I'd call it broken.
Exactly. If you are generating client proposals and 1 out of every 10 has a broken link or a hallucinated price, you lose the client. You lose trust. That 10% error rate is catastrophic for a business.
The source also mentioned some research from Anthropic that was even more dramatic, wasn't it?
Yes, for complex research tasks. They found that Opus, their top model, when combined with sub-agents, outperformed a single Opus agent by over 90%.
Wait, wow. Over a 90% improvement.
Because research is so heavy on context, a single agent just gets lost in the weeds. Sub-agents stay focused on their one piece of the puzzle.
So for those really complex tasks, it's not just a marginal gain. It's a complete transformation of capability.
It absolutely is. And this brings us to the cost versus reliability argument.
Because it does cost more tokens, right? You're running 2 agents instead of 1.
It does. You are paying for the sub-agent's processing time.
Yeah.
However, the source makes a very strong argument here. Catching a bug before a client sees a broken proposal is, frankly, priceless.
It's cheaper to pay for a few extra tokens than it is to lose a $10,000 contract because your agent sent a weird email.
Precisely. And don't forget the context pollution aspect. By offloading all that messy reasoning to a subagent, your main parent agent stays smarter for longer. You might actually save money in the long run because you aren't constantly restarting the main agent because it got confused and went off the rails.
That makes total sense.
Okay.
So we're sold on the idea. But we can't use subagents for everything, right? I shouldn't spawn a subagent to ask, what is 2 plus 2?
No, that would be definite overkill. Which brings us to our last section. Section 6, when to use them. The strategy.
What are the main criteria?
First and foremost, high sensitivity tasks.
Meaning what exactly?
Anything that is going to be seen by a human client, sending an email, generating a PDF proposal, posting to social media on their behalf.
If a human sees it, a subagent should review it first.
That is the golden rule. Don't use them for simple internal scratchpad work. If you're just brainstorming ideas for yourself, the latency and the overhead probably aren't worth it, but if it leaves the building, it needs a reviewer.
Okay. What else? What's the next trigger?
After major changes, you should
Okay.
trigger the document subagent anytime the execution scripts are modified.
Right. Keep the manual in sync with the machine.
And finally, on a schedule. The source mentions this concept of self-annealing or self-healing.
Self-healing. I like that.
Running these reviewers periodically, maybe once a week, you have a subagent that automatically runs through your entire code base and all your directives just to ensure the system is still aligned and nothing has drifted.
Like a weekly system health checkup.
Exactly. It prevents that slow, creeping drift toward failure.
It's just amazing how much this mirrors human management. You have a worker. You have a manager checking the work. You have a documentation specialist keeping all the records straight. We are literally rebuilding a corporate org chart, but with software agents.
We are. And that leads us right to the big takeaway here.
Okay, let's wrap this whole deep dive up. What's the summary?
Subagents are the managers and the QA team of your AI agency. They solve context pollution by keeping memory fresh. They solve creator bias by providing an objective outside review. And they solve documentation drift by syncing your rules with reality.
It's a complete quality control ecosystem.
It is. And if I can offer just one final provocative thought to leave everyone with,
Please do. This is always my favorite part.
I think we are seeing a massive shift in the required skill sets. We are moving from being coders to being managers of AI fleets.
Managers of AI fleets.
The core skill isn't writing the perfect script anymore. The model can write a decent script. The real skill is designing the org chart for your agents. If you treat your agent like a singular genius, like a lone wolf, it will eventually fail. It will get tired, it will hallucinate, it will drift.
But if you treat it like a department,
If you treat it like a department with specialized roles, a researcher, a reviewer, a documenter, a writer, then it scales. You are no longer building a bot. You are building an organization.
that is a really powerful way to think about it. You're not coding anymore, you're staffing.
Exactly.
And on that note, we have to close it out. We have covered the reviewer, the historian, the implementation, and most importantly, why this matters for your bottom line.
Indeed we have.
Quality Automated, Episode 9, Running Multiple Clients at Once.